Let's review some Unit 1. So remember, when we're multiplying terms, the numbers are just numbers. The coefficients are just numbers. So it's multiplying. So 6 times -3 is -18. Our exponents, when we multiply, we add our exponents. So x to the 5th and x squared with x to the 7th. And really, we have a y to the 1st here. If it was 0, we wouldn't see it. It was y to the 8th. And that's fine the way it is. Look at dividing. Well, what do we do with the coefficients? Divide them if we can. Or, well, 6 doesn't go into 3, so we simplify. 3 over 6 equals 1 over 2. And then what do we do with the exponents? We subtract. Our a's, we have 4 minus 2, so that's 2. And the bigger, we have more a's in the numerator, so we put them in the numerator. Same thing with b's. 7 minus 5 is 2, but now the bigger number is in the denominator, so we put them down there. And 2 minus 2 is 0. Well, those cancel out. We don't have those. Of course, we can rewrite it without the 1. Probably how you see it written on the test. Raised to a power. Really, we just distribute all of it. So the exponent on this 3 is 1, so we distribute it in. We do a third, and when we distribute, we multiply the exponents. Now the last thing we can do is we can actually do 3 cubed. 3 times 3 times 3, 27. So we get 27x to the 15th, y to the 6th. Remember that 0 power, everything raised to 0 power is 1, no matter what's in it. This, it could be a b, it could be a picture of a bus. Anything to the 0 power is always 1. And whenever we have negative exponents, we just move it down to the bottom of our fraction. Negative exponents, not negative numbers. Notice here, the only thing that had negative exponent was this, the x. 5 had an exponent of 1, we leave it alone. And if there are negative exponents in the denominator, we bring them up to the numerator. Rational exponents, we just have to rewrite. Our denominator becomes our radical, and our numerator becomes our exponent, either inside or outside, and vice versa. So if we have an exponent, it would be the numerator. If we had an index, it would be the denominator. So rewriting the following. This first one, 4 is an exponent of 1. We don't touch it. It's fine. It's the x that has all this stuff going on. Index becomes 3. The exponent is 2. Or put that whole thing in parentheses and raise that to the power of 2. It doesn't matter. Where it's different is that both of these things are in parentheses, so they have the 5/3. They both go in here. Index is 3. Probably easier to put it on around the outside. Letter C, now we're going the opposite direction. Rewrite as rational exponents. Remember, rational means fraction. So fraction exponents. 5b, they're both inside. 5b to the 7th. And what's the actual power here? 1. So it's 1 over 3. Our index becomes our denominator. Our power becomes the 1. Or 7 over 3 would be just for the d, but not for the 5. Because the 5 has an exponent of 1. So we could have written it separately, but that would take too long. Here, again, -5 is -5. Nothing to do there. The index that's here, remember we have an invisible 2. So it's p to the 9 over 2. Our index becomes our denominator. Our power becomes our numerator. Just rewriting there. If we look back at our simplifying, we've done a couple of these, so I'm not going to do tons. We'll do this one. We need to break down our 24. Remember, our index is 2, so we're looking for pairs of something. So 8 and 3, 4 and 2, and 2 and 2. Again, once you break it down, get rid of it. What do we have a pair of? We have a pair of 2's, so we bring a 2 on the outside. What doesn't have a pair? 2 and 3. That stays inside and they get multiplied back together. And now we're looking at the x's and the y's. x to the fifth. All we're doing is dividing the exponents. 5 divided by 2 comes out 2 full times, but we have 1 left over. 8 divided by 2 for the y's is 4, none left over. That's it. We do the same thing with, if there's something on the outside, we just kind of leave it alone. We'll rewrite it. And now we're looking for group of 3 in here. 54, we can break down to 9 and 6. Again, once you break it down, get rid of it. Got a group of 3's, so I'm bringing out a 3, but I still have a 2 left over. X, well, there's no groups of 3 there. Y to the 10th, 10 divided by 3 was 3 times, with 1 remainder. And z to the 6th, 6 divided by 3 is 2, no remainder. Now I just put this together. So negative 7, negative 3, negative 21. X to the 5th, x to the 3rd, remember we add our exponents. Y to the 1st, and y to the 3rd is y to the 4th. Z squared, because there's no other z out there. And then our leftovers, things that didn't have parts. So it took a couple steps, but it wasn't all that difficult. Alright, I zoomed out to do our classifying our numbers. Remember, if we have a Venn diagram, we should be able to label it. Smallest is natural, that's whole, integer is rational, got the numbers in there. So we're placing all these numbers in the smallest box they go into. 0 is whole, it's the only number ever going to be in there. Rational, negative 1/2 is a fraction, negative 4 is an integer, 0.63 can be written as a decimal, and what's in here as well. 2, natural number, we can see 2 is something. Top, of course, is rational, decimal goes on forever and ever and doesn't repeat. What's the square root of 2? There is no perfect square root of 2. You put in a calculator, you get a bunch of decimals. Negative 5, along with negative 4. Square root of 16 really is 4, so I kind of tricked us. And where does 4 belong? But it's still classified as square root of 16 because that's what it is. 0.3 repeated, repeating decimals, written as fractions. So it's rational. E, irrational. One of our famous irrational numbers. Pi, E, square root of non-perfect squares. Cube root of 8, we're looking for 3 of something. That's what we're looking for. We have 3 of something with nothing left over. So the cube root of 8 is 2. So again, I kind of tricked you, a natural number. Because it's just 2. 5, natural number. 3/4, a fraction. Negative root 5, doesn't matter if it's negative or positive, it's irrational. Negative 5 over rational. 7, natural number. Counting number, 10, natural number, we're losing room. And last, 0.8 repeated, the repeating decimal, is rational. We need to know those rules without the calculator, or without notes.